Okay. Um, oh, before I start, remember I mentioned the possibility of having the labs virtual instead of in person. Does anybody object to that? Again, is okay. So I'll put a Zoom link in the. It'll be in the lesson part where it is. So everybody has Zoom, okay? And the the next well, what the assignments so far have been fairly straightforward. I mean, easy, I hope. um, but they're going to be kind of ratcheting up a bit, just to warn you. So this next one is a little bit more challenging. So you'll have to kind of give it some thought, but. Uh, and so what the next assignment will be posted actually right after class, so you can start working on it, and if you finish it by the lab tomorrow, then you can kind of have an extra coffee break or something, or play an extra level of your favorite video game, whatever you do. Okay. Um, okay. I I keep asking the same thing and then never getting. Keep asking about sort of okay, what is there anything that's still not quite clear for you? I mean, or is there something that you feel you want to ask but don't know how to ask it? Or is everything like just absolutely perfectly crystal clear?
No questions yet,
Nope.
but I suspect I'll start asking them shortly in the next couple classes.
Okay. Yeah.
No, it's mostly review so far.
Yeah. Oh, and then, well, the other, just as a reminder too, that there's still going to be a quiz on Sakai. Again, you can, because it's on Sakai, you can kind of take it wherever you are. Um, if you're like a lot of us, the idea of kind of not having to come in on Friday is kind of a benefit. So that's the hope there. Okay, so um, we're starting to really get into the stuff about classes and objects and stuff like that. And the way that Java does it, in my of all the uh, all of the mainline languages, Java does a better job of that, in my estimation, than all of the mainline languages. Better than C++ in my, certainly, Python's object model is very confusing to me. But again, I don't want to keep bashing Python. But I mean, Python is great for certain tasks when it comes to, and I implemented a fairly substantial object-oriented program in Python, but it was kind of agony, especially after Java. There are languages that have better, in my opinion, object models than Java. The thing is that they're not mainstream. They're not ones that you're going to use. And in fact, the work I've been doing for NavSup has mostly come about because they had an application that they liked, but they wanted it ported to Java. So that's how I started working with them. Why? Because they wanted it to be in Java. I told them that they had a perfectly good program, but it wasn't in Java. But they wanted it in Java, so okay, so anyway, all right. So today, so class libraries. If you remember, one of the motivations for Java, one of the attractiveness of Java was it compared with other main languages at the time, it was relatively small. And there is a sense in which that's still true. The core Java language is still relatively small. Yes, question? Oh, figure you're, okay, thanks. All right. What's become large and even some might argue bloated are the class libraries, and those were originally relatively small, but they've become very huge. Some would argue bloated, but and that's a two-edged sword, because on the one hand, there's just a lot of stuff, and there's a ton of things to kind of keep track of. And as I've, for me personally, it was kind of a psychological thing where my I always want to be able to kind of know everything about whatever it is I'm using, and with Java that just hasn't been possible. They've actually been adding things faster than I can assimilate them. And then in recent versions, to be honest, they've been adding things that I find, well, questionable. So that, nevertheless, if so understanding these class libraries, and the thing is that if you're going to use somebody's, if there's a task you need to do, you have basically two choices. You can either write it yourself, or you can find somebody who's already written it and use that. If the task is in the Java standard library, then your best option is to use that instead of rolling your own. Because the people who wrote Java are much better programmers. Well, I won't speak for you, but they're much better programmers than I am. And so I won't be able to do better than they when it comes to a given task. So if they've done it, it's always going to be better to use that. So why write any programs? Well, because the things that we write are things that are not in Java. The simulations that I write, they're not part of the Java, and they shouldn't be. Okay, but there's a huge amount of just remarkable functionality in there. So if there's a task, a programming task that you want to do, then the chances are it's in the standard Java library. And if it isn't in the standard library, the chances are there's actually an open source jar file that you can kind of grab and actually use. I have never found a task that I couldn't do with either the standard libraries or with an external one. And sometimes there are libraries, open source libraries that do a job a little bit better. I mean, one example is Java has a very nice logging feature, but there's actually a better one that the Apache consortium came up with. And so for simple programs, I use Java's logging. For my production programs, I use the Apache one. Why? Because it has a lot more functionality. So, okay, so we'll talk about packages, and then do a look at this random class a little bit more, because that's one thing that we're going to be using. And then I'm going to introduce something called enumerated types. And the enumerated types were not part of the original Java, but they came into, it was kind of interesting the way they came about. There was well, I'll talk about that when we get around to it. So, objectives for today's class is to understand how Java uses packages to organize code. We've touched that a little bit. We'll do a deeper dive. Understand what import does and what it doesn't do. So it's Java, in a way, they've kind of used it in a slightly misleading way. We'll talk about that. And then just have a little bit more experience with this random class. For some reason, the book does not really utilize all of the capabilities of the random class for whatever reason. And then being able to declare an enumerated type, or a so-called enum. I'll actually give time permitting, I'll kind of work through an example of live coding. Okay, so class library. This is something which we can use, either the built-in ones or external ones. Toward the end of the quarter, I'm planning on having an example of using an external library for certain tasks. Like, so for example, well, the one that we'll be looking at is if we want to read in a comma-separated file. Are you familiar with that is? Okay, so reading in a comma-separated file is a bit tricky. What we'll do is when we learn some more of the capabilities of regular expressions and strings and things like that, we'll be able to kind of easily read in a comma-separated file that doesn't have too many weird things in it. But comma-separated files can have some weird stuff in it. And it turns out that there's an open source library that handles all that weird stuff in a very nice way. So it'll be an example of kind of using a class library that's external to Java itself. So, but the Java standard class library is part of every Java development environment. It has just a lot of really wonderful capabilities. So it's not part of the core language. The core language is still relatively small. And you know, we've seen some examples. So far, things like system. You know, right from the get-go when we were doing Hello World, there was a class. There's a class called system, and it has capabilities which interact with your system. Scanner, we've used scanner as string. These are all part of the standard class library. So string, you know, even though strings are very important, string itself is not part of the core language. It's actually a part of a class as part of the class library. And sometimes it's called a Java API or Application Programmer Interface. You know, you're familiar with that acronym. I know that you don't have enough acronyms. You always need a few more. Now, one of the nice things that Java didn't invent this, but they were the first major language to really incorporate stuff like this. So there's an online Java API documentation, which reports the things like the name of the class. In this case, I don't know. So here's the class string. It shows you what package it's in. So it's in the java.lang package. We'll talk a little bit more about what that's about. Implemented interfaces. Next week we're going to talk about what interfaces are and what that's about, so we don't have to worry there. But okay, so here's its class. Now notice that it has a keyword final. We haven't used that keyword yet, and we're in many cases we're not going to. What final does, what it says, and it can be applied to a class, to a method, or to a variable. And what final means is you can't be changed. So in this context, it means that we cannot subclass string. Because why? Because they declared it to be final. It said no, it's all locked up tight. You can't muck with it. But then, you know, down below, and we've seen some examples of this. One of the neat things is that in your code, you can create these using the JavaDoc tool, and what it does is it like all this information here is part of the JavaDoc comments, which are a slash with 2 stars and ending with a star and a slash. So that. Okay, so now the packages are how Java organizes things. And what's nice about that is that you can put classes that have similar functionality into the same package. So the Java Lang package contains classes which we just sort of normally use a lot, like string, like there are numerical wrappers, object wrappers that are all in there. System is in there, so they're, in other words, things that you would kind of use as a matter of course are all in there. But there are others. So for example, we've seen scanner was in part of java.util, or no, I'm sorry, random was. Why? Because random isn't something that you often use, but it's kind of a utility, as it were. Java was one of the first languages to build in, or at least between the language and the standard libraries, the ability to work over the network. So there are classes where you can set up a socket. You can set very low level. You can set up higher level things where you can interact with web pages, with whatever. All of the internet protocols can be built in and used in a fairly nice way. So for example, if we wanted to do some screen scraping, we can actually use that scanner class we can set up a URL connection, turn it into, get an input stream for that, feed that stream into scanner, and then at that point, scanner would treat the remote page just like as if it were either somebody typing on the console or even a local file. So that's the one of the fundamental principles of object-oriented design is what I call the principle of ignorance and apathy. That comes from they were taking a poll and they asked people, what do you think about the terrible problem in society about ignorance and apathy? And the most common response is, I don't know and I don't care. So ignorance and apathy means that in this case, if the scanner class doesn't know or care where that data are coming from. It could be coming from the command line, as we've seen. It could be coming from a file, as we will see at some point, or it could come from an internet connection, or it could just come from some place, anywhere. So it doesn't know or care. All it knows is it's getting a stream of text, and it's going to do something with them. Okay, so now the import. Now we've seen a little bit of the import. One of the nice things about NetBeans is that it creates the import for us if we say fix imports. This was actually kind of a bait and switch that Java pulled, at the time, again, C++ and C were kind of some of the dominant languages for this kind of thing. And in those, they had a thing called the include statement. And what the include statement did was it kind of pulled in stuff from other places. But it literally included it. Now, Java wanted to make C programmers feel kind of comfortable, so they wanted things to kind of look very similar. So they have this import statement. All right, so now what's that about? Okay, so now remember we're talking about packages. So every class, or at least should be in a named package. If you remember, I mentioned that kind of a few weeks ago. So every class should be in a named package. One of the implications of that, or the way that Java handles things, is the fully qualified name, the actual name of the class, so the actual name of the scanner class is this whole thing. So it's like the name on your birth certificate is your fully qualified name. But if you're talking to somebody, you know, you usually either, you'll either, well, you just kind of use the plain name. So, but this is the real name. This is the fully qualified name. And the thing is that you never, the import statements are not necessary at all. If we didn't want to use an import statement and we wanted to use scanner, we can use this fully qualified name of that, and it would work. Why? Because that's its name. So what is import about? Well, if we have this statement, then what this says is, this is the fully qualified name of the scanner class, and so you can simply use scanner by itself without the package name when you're referring to it. So in other words, yeah, so basically, now, and the book sort of talks about this and then says, oh, you know, well, it's, you know, not the best idea, and it's something which, don't do it. So this, and you'll see some, the argument for this is that, okay, if I do this, then whatever's in there I can just kind of use. This, though, violates my prime directive of programmer's intent. In other words, if in a larger class, and classes shouldn't be too large, but they can get fairly large, there will be a number of different packages that you're using classes from. And if they use this star thing, then when I see a class, I don't know which package it's from. On the other hand, and the thing is that what does it cost to have every class you're using be explicitly done? It costs a single right click. You say right click and say fix imports, and then NetBeans will do this all for you. So always do this, do not do this. Okay, so what is import actually import? And this was sort of the little bait and switch that they did. Import doesn't import anything. Import does not import anything. It just allows the use of the unqualified name. That's all it does. So it's sort of a little misleading, because import sounds like include. It sounds like you're actually kind of doing something. The fact is you're not. So remember, for every class, the fully qualified name is the package name dot the class name. So, I mean, here's another example. Java util random, that's the fully qualified name. The unqualified name is simply random. And again, we can always use the fully qualified name with no import statements. That's always possible. Sometimes it's actually necessary. Very rare, but there have been occasions where I've used classes from two different packages that happen to have the same actual unqualified name. It happens occasionally. And in that case, you have to kind of pick your poison. So in those cases, the one that I use the most, I would have the import statement for, and then the other one I use the fully qualified name for. That, you know, and that's the only way to get out of that situation. Now I say, well, what about, you know, we've been using string and some other stuff. You know, what's with that? Well, the thing is that the classes in the Java Lang package are automatically imported. And you know why? Because they're the ones which are commonly used. I mean, they're part of just any stuff that you're going to be doing. There's going to be a lot of stuff in the Java Lang package. So it would be as if they kind of did this, but you know, system and string, are both in Java Lang. We never had to say import, even, and we could just refer to them that way. So, but on the other hand, a class like Scanner, which is not in Java Lang, we have to import it if we want to use the unqualified name. Okay, so any questions about that? And just to be clear, so and here the thing about the packages is that, well, kind of as I think I've shared is that my programming began on punch cards in the Fortran language back when dinosaurs ruled the world. And there was no notion of anything, about any of this stuff. It just had, the program was all kind of in one place. When things got really big, and if you look at the Java standard library, there's like a ton of stuff in there. We can even take a peek at that. You can't just sort of put it all in one thing. I mean, it's like, just consider, you're taking, 4 courses every quarter? Do you put all of the material for all of your courses into one folder, into your, no, I mean, you separate them out by class, right? Because stuff that we do here is going to be very different than the things that you do in other classes. And so it makes sense to put all the stuff from one in one place and the other. And then when it comes to organizing the classes for Java, is pretty much the same thing. The other nice thing about that is that and I've mentioned this before, but it bears reminding again, is that a class is always in a file of the same name. So the random class is in the source code for that is in a file called random.java. And if we were to try to locate that in a file system, if you had the source code for this, it would be in a directory where Java is the top directory and util is the one under that. So similarly, the ones that we've been writing here, the package name is CS2173, lowercase. And so the files are literally located in where are we here? So we can actually can you see? For some reason I can't. Okay, so if I click on the Files tab here, what this is this is looking at the directory. So this is a directory. If you were to go on the file system and find this is actually where it is. Every class in here, so far because it's in the CS2173 package, let's see what was, the first line is the package, but that means that is going to be in a directory called CS2173. Now that directory can be embedded deeply in the file structure anywhere. I mean, in fact, in this case, it's wherever it happens to be. But the directory that it's in has to be that. And if there are more than one, then it would be subdirectories. And in fact, what we can do, let's see, see when it says library? So here's this is the standard class library for Java. And if we just sort of take a look at that, you see these are all the packages that come with the standard Java library. So here's is that, yeah. So you see there's just a ton of stuff there. Anyway, okay, so we don't. All right. So now back to random. So here's, we've touched on random a bunch of times. Next quarter, we're actually going to use a different approach to random numbers when we do simulations. But, okay, just to just to illustrate what I was saying before, what if I delete this import package, import statement? Okay, so now I'm getting the red squiggly, and I hover and it says it cannot find symbol. So now the antidote to that is right click and say fix imports, and then it puts the import back in. But just to kind of show you, because that is not necessary, if I do this, just everywhere I'm referring to it, then no red squiggly, and it actually works. Okay, so what have I done here? Everywhere I'm using the class name, I've replaced the unqualified name with the fully qualified name, and then having defined this variable as an instance of that and instantiated it using its constructor, now I can apply it. So here are some. This isn't even all of the methods that are available to random. So we have nextInt. This is not terribly useful because the nextInt produces a pseudo-random number which is between 0 and the maximum value of an int minus 1. There aren't many cases where you really want, I mean, I can't think of a single instance where you might want to do that, unless you were kind of then trying to generate your own kind of uniform things, but you wouldn't want to do that because actually you would want to use next double. But okay, so now the two most useful applications of nextInt are, and that's because it is overloaded, and I've been using that term. Later we'll kind of circle back to what overloaded means, but basically it means that you can have multiple methods of the same name, as long as they have a different signature. And what's the signature? The signature are the arguments the types of arguments that you put in. So the signature for this nextInt is empty, or 0 argument. The signature for nextInt on this one is an int. So if I call nextInt and pass it an int, then it will actually go to a different method. And in this case, this will generate a uniform random integer between 0 and 19. So now the thing to understand is that the bound, that is the top number, is exclusive. So it goes, in this case, 0 to 19, or I can give it an explicit lower bound. So the lower bound is, or the origin as they call it, is inclusive, and the upper bound is exclusive. So this will produce random integers between 1 and 6. Now next double produces a uniform a uniform between 0 and 1. So that's a floating point number. And it also has the bounds and origin. So next double 20 will produce a continuous uniform random number between 0 and 19. And similar, I'm sorry, let me take that back. It'll go uniform 0 to 20, but remember, for a continuous random, you've all had probability, right? No? Yes? Okay, yeah. So a continuous uniform value will never take on any of its extremes. So uniform 0 to 20, it'll never be 20. It'll always be strictly less than 20. And likewise, this would be uniform 0 to 1. It would never be 0. It would never be 1. And so here, this would be a continuous uniform between 20 and 50. So I can, and again, for whatever reason, what the book does is the book kind of uses this one and then kind of mucks with it. It's always, again, the principle here is that if I got a method that does exactly what you want, use that method. Now, it also has a Gaussian. You remember what Gaussian is? You know, no, normal. The normal distribution, you know, bell-shaped curve. And it's called Gaussian because it was invented by Laplace about a decade before. But Gauss was kind of a big gun, and so we got his name on it. So anyway, so next Gaussian will generate a uniform, a random variable having a standard normal distribution, or next Gaussian one. In this case, this would give a mean of 100 and a standard deviation of 2. Now, one of the little issues that you need to deal with when doing stuff like this is if you're generating normals, or Gaussian is sort of the classy way to say it. A mean, understood, but is this going to be the standard deviation or the variance? Is it obvious? No. Okay, so how can you find that out? Well, that's where the JavaDoc comes in. So is that going to, you know, looking at it, it is not at all obvious. And so if I go, let's see, if I show the JavaDoc, it called mean and std, it returns a double pseudorandom show from a Gaussian normal distribution with mean and standard deviation specified by the arguments. Okay, so the JavaDoc says, okay, it's standard deviation, but always check that, because if you're using this and you think it's the variance, but it's really the standard deviation, or vice versa, then you're going to have weird results. Okay, so how can we run this? Yes.
So that next Gaussian, I know that the JavaDoc says the arguments are doubles, but if you put them in as integers, does that just throw an error?
No. That's in almost every case, and this gets back to kind of the internal promotion things. When we're working with, if I use an integer in a context where a double is kind of required, it will upgrade the into a double. I can't go the other way. If a method requires an integer, so like up here, I couldn't put in 20.0. See, I get a red squiggly here. It says incompatible types, double to int. You know, so I can't do that. But here, no complaints, because can I always convert an integer into a double? And the answer is yes, and Java does it for me. And there's a part of me that actually objects to this because it gets back to programmer intent. One of the things that I like to kind of insist on is to make it absolutely clear. So it's like if I see this here, then if I'm reading this, it's not 100% clear to me whether a double is required or an integer is required. In other words, if I see this, I might be under the impression that this method requires 2 integers. And that's not the case. It requires 2 doubles. So Java's kind of doing stuff under the hood for me that I don't necessarily want. But this would still work. I mean, it's not a mortal sin, but it's a mild violation of programmer intent. In other words, if I'm putting in a double value that I intend to be double, even if it's an integer quantity, I want to always put in the decimal point, just to make it clear, yes, I intended that to be a double. Yeah. Okay, so when we run this, we see, you know, so here we get all these different things, and so, okay, so that's that. Okay, I'll talk a little bit about enumerated types because, as we'll see, that's kind of a very useful thing. Enumerated types are the antidote to what's called the magic number. You're probably familiar with the magic number. So here's an example. Supposing we have an application where we're interested in what season it is for whatever reason, okay? And there, at least, well, in every part of the world except Central California and other, on the East Coast they have 4 seasons. Here we only have 3. So, and they're actually there's spring, summer, and fog. Those are the 3 Monterey seasons. Anyway, but in applications prior to this, what you would do is you would have a magic integer. So you would say, oh, if so you'd have a variable called season, but it would be an int. And if the season is 0, then we'll say it's winter, 1 spring, 2 summer, 3 fall, say. Now what's the problem with that?
You can operate on that magic number.
Yeah, I can say add 1 to winter. You know, what the heck does that mean? Even worse, if I have methods where I'm passing this to, what the signature would be an int. But the only legitimate ints in this case would be 0, 1, 2, and 3. But what would happen if I passed it -1 or 5 or 1,000? The compiler would not pick that up. The compiler would say, hey, you want, this requires an int, you're giving me an int. It's a lousy int, but you know. So that's the way things were done up until this concept of an enum came in. So what an enum is, it's basically, the idea is that it's going to create under the hood 4 objects and only 4 objects. And so if I declare something to be a season, then the only values I can put in this case would be winter, spring, summer, and fall. I can't put anything else in. I can't put an arbitrary integer in. The only thing other than this I could put in would be a null, because they're objects. Oops. And so it's up to the, in this case there were 4, I could have 20, I could have 15. So we would, it's a type just like a class, so I could declare a variable of type season, but now I can assign it a concrete value by using the dot operator. And so they're type safe, unlike the magic int, where and what people found was that when they used the magic int, because there was essentially no other option, that bad data would eventually get in. Murphy's Law. But these enumerated type are type safe. That error cannot occur. That error cannot occur. Now, and then it turns out that that sometimes we do want to either manipulate them or refine them in some other way. So internally, they're actually they have a magic int, but it's all internal. We can actually get what that value is. And we can actually get a list of all of them in an array. But we can't assign a numeric value to it. So it's essentially it's a special type of class, and each variable of that type is in fact an object. But what's special about it is there can only be the ones that we define. And this is the only case of that. Or we can programmatically you can do something equivalent to this. And what's interesting is that what happened was Java programmers, when the earlier versions of Java didn't have this capability, but Java programmers discovered that there was a way of defining classes so that this happened. It would use the final key. They would define static instances using the final keyword and lock everything up, and so they had that functionality. And what was interesting was that the Java developers saw that this was a very common pattern, And they said, okay, this is really common. This is a really good idea because it overcomes the problems of magic ints. And so we'll put it into the language itself. So that was, in a way, it's kind of like, you know, there are these situations where kind of the fans kind of give feedback to the, to like a show or something like that. Remember, like in was it, yeah, in Game of Thrones, are you familiar with that at all? Or there was one point where one of the characters, Gendry, was kind of rowing somewhere, and then the show just kind of dropped him. So on the fan pages, they were saying, well, he's still probably rowing somewhere. And so later in the show, somebody actually kind of said that line. And it was kind of like based on what the fans were kind of talking about. So, but this is a case where the Java developers put this capability in because they saw programmers using it a lot, and it was a really good thing. And in fact, under the hood, interestingly, when you kind of peek under the hood about how it does it exactly the way the programmers were kind of doing it by hand. So, okay, so I think I have time to do this. So let's. Oops, where are we here? All right, so here's how we. All right, let me undo this here. Don't need that. All right, so we can actually create them. So let's. Here's how we do a right click. I say new. Okay, it's not listed, so I look for other. And there is a Java enum. And I think I call it a day enum, so let's call it day. Now the okay, so now notice that it says instead of public class, it says public enum. And what are the days? Well, we have Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. Okay? So what this does is now day is like a, you know, under the hood, it actually is a class, but it has created, it will create exactly 7 objects of type day and no more. So if I want to kind of use this, okay, now notice, okay, notice I don't need an import here. Why don't I need an import? Because the day class is in the same package. So if I have 2 classes in the same package, I don't have to worry about import. It gets put in automatically. Okay, so what is, now, the fully qualified name would be Thursday in this case. And what it also does under the hood is it's toString. Its toString actually automatically prints out the name that I've given it. So if I print it, then there it is. Now, all right, so what if I don't want to use the fully qualified name, but I want to use the unqualified name? Okay, so now it can't find the symbol. Why? Because it imported I don't have to import the package, but when it comes to all the stuff on the inside, I actually do have to import it. So let's see if NetBeans can find it. So I say fix imports, and it actually kind of does it. Now because because of the way that it's defined, it adds this extra static modifier. But now, and it will print what tomorrow is. So I can use it, I can either use the qualified or the unqualified. And the other thing, if I have a say, I can use it in a switch statement. And here, so here's, now interestingly, in a switch statement, I can't use the fully qualified name. Okay, so okay, so what am I doing here? Here's notice that I can switch on an enum, and in this case, I'm just trying to identify which are the ones for the weekend and which ones are for the weekday. For whatever reason. Okay, when I run it, it says okay, Friday is in fact the weekday. So. Okay, so that's how we use enums, and then okay, I'm just a little bit over. Right, basically that's theirs. Okay, so start reading the next chapter, and then now next week we're going to start really diving into what writing classes is about and organizing our objects in a way to actually kind of do stuff. So that will be, the assignment should be posted. Don't forget that there's still a quiz, so wherever you are, log in at 9 and take the quiz. So, but I'll see you on Zoom tomorrow.